Notes 3-16 Quadratic Applications. Today you will use quadratic equations to solve real-world problems. So the first problem, you are standing on the baseline of a tennis court and you want to practice your soccer skills. You want to kick the soccer ball from one baseline to the other 78 feet away, but at the same time only clear the 3-foot net by 1 foot. The ball will travel in a parabolic path with the highest point being 1 foot above the net. Part A. Draw a picture and label key points. Okay, so if we're going to kick, if we have this person here, and he's going to kick the ball in a parabolic path, okay, then it's going to look something like this. Where he begins to kick the ball, we're going to call that point just 0, 0. So I'm going to label this point right here. Okay. Now, the other thing that it says is that the baseline on the other side is 78 feet away. So we're going to label this point based off of a coordinate plane. So if this is 78 feet away, that's a horizontal distance. So the horizontal distance x is going to be 78 feet. And then the vertical distance, well, it's the same. It's at the bottom, so that would be 0. Okay. And then it says he wants to clear the 3-foot net by 1 foot. So that's going to be like at its highest point. So this point right here, our vertex, it's going to be halfway between 0 and the 78, right? Because from here to here is 78 feet. The vertex should be halfway. And so half of 78 is 39. So the horizontal distance is 39. And then the vertical distance, they wanted to clear that 3-foot net by 1 foot. So it's going to be 3 feet plus 1 feet, which is 4 feet. So my vertex is 39, 4. Okay. Now they want us to describe a reasonable domain and range. This is important for when we type these in on our calculator, because we're going to want to see this picture on our calculator, and therefore we need the domain and the range. Well, the domain, if you remember, is from left to right. So if you look at this picture, the left side is at 0 and the right side is at 78. So I would say that a good domain, that's a terrible parenthesis, a good domain is from 0. So it's when x is between 0. And let's just go ahead and round off the 78. Let's make that 80 so we can get a little bit of room on each side, or on the right side, to see it. Now the range, again, we're using this to get a good window on our calculator. The range, well, the bottom value of our range is at 0, so the y value is going to be between 0 and 39, so let's just go ahead and say 40. No, I'm sorry, that's wrong. I'm sorry, the vertical distance is 4, so let's just go ahead and say, here, let me erase this, sorry. Let's go ahead and make that a 5 to give us a little bit of wiggle room on the end there. Okay, so now we want to write an equation in vertex form relating the height of the ball to the distance traveled. So, to do this, you need to have 2 points. Well, we have our vertex, right? And this is just like what we've been doing. When you're given 2 points, write the equation. Well, there's my vertex, and then one of my other points that's on this parabola is the point 0, 0, and that would be a good one to use because it's super easy with bunches of zeros. So my vertex form is y equals a parentheses x minus h quantity squared plus k. Now you've done this before, so go ahead and pause the video and let's see if you can do this on your own, and then when you're ready to check the equation with mine, go ahead and hit play again. Okay, boxed is the equation that I got. Hopefully you got the same equation. Okay, the next question is the vertex a max or a min? Well, because it opens down, then the vertex is a max, because it's at the top of the parabola. And then list the transformations in regard to the parent function. So this is based off of the quadratic parent function, which, if you'll remember, is at the origin 0, 0. So from this parabola to the parabola in our problem, which is this one here, what are the transformations? Well, number one, it reflected over the x-axis. And then number two, it moved to the right 39, so it translated right 39 and up 4. Okay, so those are the transformations. Alright, moving on to number 2. We're going to do some of this in the video, and then some of this I'm going to show you in class tomorrow because we'll need a graphing calculator. Number 2, an arrow is shot over a lake from a cliff that is 20 feet above the lake. So right off the bat, I'm going to say that this cliff right here is 20 feet. I'm just going to kind of label that, so that's 20 feet tall. The arrow returns to the same height as the cliff, so over here at the same height of the cliff, at a distance of 160 feet from the cliff. Its path traces a parabola and reaches a height of 60 feet above the lake. So that should get marked out, above the lake. Label the key points on the given picture. Okay, so first what we need to do is we need to be able to label our picture. So what I'm going to do is I'm going to label the beginning point. Because it has a vertical distance of 20, we're going to say that that is 0, 20. Okay? And it said that the height, the max height, was 60 feet above the lake. So we know that the vertical distance of that vertex is going to be 60 feet. Okay, the other thing that it tells me is that over here, at an equal height as a cliff, that's 160 feet. So this is 160 feet horizontally from the cliff, but it has the same height vertically as the cliff. So this point right here is going to be 160, 20. And then the vertex is going to be in the middle of that, and so that's going to be 80, 60. Okay, so there's the key points. Now, describe a reasonable domain and range. Well, the domain, again, goes from the left side to the right side. So we're going to say it goes from 0, so it's when x is between 0 and it's actually going to go a little bit further than 160 because remember it has to go down here. So let's just make it to 200 just to kind of give it enough room. And then the range is from the bottom, which is at 0. So y is going to be between 0 and 60 feet. So let's just go ahead and make it 75 feet just to give us a little bit of room. Again, that the end point doesn't need to match exactly, but you do need to give it a little bit of room. Alright, so write an equation that relates the height of the arrow above the lake to its horizontal distance from the cliff. So we're going to have to use some points. So my vertex is 80, 60. And let's just use one of the points. We're going to use 0, 20 because it's got a little bit smaller numbers. Okay? So pause the video and I want you to practice putting it written as an equation. So start it back when you're ready to check your answer. Okay, so boxed is the equation that I got for this parabola. Now it says create a table showing the arrow's height every 30 feet to the nearest hundredths. So you can go ahead and fill that in yourself. You can just plug in the x values, the distance every 30 feet to the nearest hundredth. So let's make the first x value 30, and then 60, then 90, and then another 30 would be 120, and then 150, 180, and then 210. Okay, so use those values, plug them into the equation to figure out what your y value height is, and I'm going to have you fill that in and come to class with that tomorrow. The rest of the last three problems, I want you to be thinking about how you would find those, and I want you to try and find them on your own. And then tomorrow, I will show you some ways that you can use your graphing calculator to find those answers a little bit faster. Okay, so I will see you in class. Come to class with your notes filled in, and please don't forget to bring them to class, because I will need you to have them in front of you. All right, have a good evening.